Okay, so the question that gave folks a little bit of trouble on MSL2 was this one, number 4, which asks you in the first part to find the sample covariance. I'm just going to go ahead and run through this to show you how to do it. First of all, I'll click here. I don't know, I've tried to open it in Excel. That involves a file download. It's kind of a pain. I usually just copy it to the clipboard, and then I'm done, and then I paste it here. Okay, so I got the data, and now I need to compute the sample covariance as the first part. So, there are several ways to do this. I think I'm going to show you the long way first, as usual, but notice that the formula, if you go back to the slides, you'll see that what we have to do to find the sample covariance is to take the product of these differences from the observation to the mean for the x variable and multiply that by the difference from, in the same row of the y observation and the y mean. And then we divide that by n minus 1. Okay, so let's go ahead and do this. I'm going to add 2 columns here, and I'm going to call this one x minus x bar. And so I'm in this column, I'm going to be doing this expression right here. And then I'm going to add another column to compute that expression right there. So that's going to be y minus y bar. Y minus y bar. Okay, and so what we mean by these are just the averages. So I'm going to take the mean first of all. So just going to take the average of the x variables. That's going to give me my x bar. And I'll do that. I'll do the same over here. I can actually just copy and paste this, and it'll adjust the column. Okay, so now I have the means. So now all I need to do is take, set this column equal to, so x minus x bar, okay? And then I'm going to hit F4 to make that an absolute reference, okay? All right, so now I'm just going to copy that down. So for each of these rows, it's computing for the x variable, the difference between that x and the mean x, okay? So now we'll do the same for y minus y bar. So that'll be equal to whatever is here, y, minus y bar, okay? And F4 for the absolute reference, okay? I'll copy that and then just paste it down here. Okay, so now the next part of this equation here, or this formula, is to multiply those two together, okay? So I'll have another column here where I'll multiply these together, and I'm just going to call this column the product. So just take this times this, okay? And again, just copy it down. Okay, and now I just, now that I have all these products, now I just need to add them all up. That's what this summation sign here is telling us to do. So I'll just call this the sum, and just set that equal to the sum of all of these. Okay, and now we're almost there. We just have to divide by n minus 1. So I'll just call this will be the covariance. So just set that equal to, and so n, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n minus 1 would be 10. Okay, so this is our covariance, and I think we were supposed to round to 3 decimal places, so we'll just have Excel do it. So 59.382. Okay, so another way to calculate this, and we'll just do this one, COV. We could have just told Excel to do the whole thing simply by doing equals and then covariance and then S, because we want the sample covariance, and then we select all these and put a comma, and then select all these and close the paren. And so we have the same answer once we format it as a number with 3 decimal places. Okay. Now, so we see these are the same. Of course, it'd be a surprise if they weren't. Now, there's another way to do this, and this way has a little bit of a trick, and I'm going to show that to you. Some of you may have noticed that if you come here to data and data analysis, you have a covariance choice here. So let's go ahead and see what this gives us. So it asks you for an input range, and then over here it tells you that you can stipulate that you have the labels in the top row and that the columns are the groupings of the variables. So we'll click there, select X and Y, those are the labels, and then I'm just going to put put the output right over here somewhere, okay, and go ahead and do it. Okay, now this may look a little bit odd because they actually give us 3 numbers here. It's a matrix, and how do we read this? Well, what it's doing is describing the relationship between these 2 variables. Now, this is the covariance of x, and the covariance of a variable with itself is just the variance of the variable. So that is just the variance of x right there. And this is just the variance of y. But what is this? This isn't, so this should be the covariance, but that's not what we calculated over here. This is a little bit different. Well, you may have noticed that the function for Excel gave you the option of selecting the covariance of P or the covariance of S. So if we were to calculate the covariance of P, using the population covariance, and then putting in this range, and then doing comma, putting in this range again, we see that it gives us that answer. So, this is one case where the data analysis tool pack does let you calculate the covariance, but it's actually the population covariance, which is not what the problem asked for. Okay, so you could compute it manually, as we did here, or you could use the Excel covariance.s function. But be aware that if you use the covariance under the data analysis tool pack, that it gives you a slightly different covariance. Okay, so hopefully this one's right. I'll go ahead and put it in to make sure. 59.382. Okay, so 59.382. Check answer. Okay, so that worked. Okay, so now we have to compute the coefficient of correlation. Once again, there's an easy way and a hard way. We might as well do the hard way first. So, or actually, let's just do the easy way first. So now we want to have the correlation coefficient, and we could simply use Excel. And Excel has a function correl, and we select this range, put a comma, and then select this range, and close paren, and we see that there's a correlation coefficient of 1. Now this should give us some pause, because this means that if this is correct, then these variables are perfectly correlated. But if you take a look at them, notice that we have 16 and 32, so it's doubled. 10 and 20, it's doubled. 19 and 38, it's doubled. So in every case, y is just 2 times x. So these are perfectly correlated variables. So 1 is the correct answer for the correlation coefficient. Okay. Now, the other way we could find that is, remember that the correlation coefficient is, and let me just go back to the slide here. If we go back a few slides, we'll see that this is this R. So the correlation coefficient is the covariance of the variables, which we already have, divided by the product of their standard deviations. Okay, so let's do it that way and see if we get those same answers. So we need the standard deviation now. So standard deviation of x is going to be, we'll use the sample as we always should. So standard deviation of x is that. Okay, standard deviation of y is this. And okay, so now we want to divide the covariance by that product of those. So let's put that here. So we're going to do, this is going to be equal to this divided by this times this. Okay, and we get something that's awfully close to 1. Because we're dealing with a bunch of decimal places here. It's there's probably a little bit of a rounding error, but if we were to round this, it would be 1. Okay, so I'm gonna go ahead and round this to, let's see if we can get that closer to 1 if we use F14 or F15. Let's see if that reduces some of the rounding error. No, okay. All right, so let me go here and okay, so we'll do 1.000. Okay, so correlation. Okay, now, so see, I kind of touched on this when I was talking about this perfect positive correlation. So it's positive, so that means this is an upward sloping line. So y is equal to 2 times x. So how strong is the relationship? Well, it's very strong, and it is positive because as x increases, so it's strong. But then let's look at what the other answers are. It's a perfect negative. That's not right. No correlation. That's not right. They have a perfect positive correlation. Okay, so even though this one is true, this one actually describes the case with more precision. So it's a perfect positive correlation. So we'll pick D, and that's that. Okay. All right. So as I said, that one was either not attempted or was done incorrectly. So as you prepare for the exam, I hope that this helps clarify, how you find a covariance and a correlation coefficient.